Chemists are good at inventing things. We create things. We're molecular engineers, if you will. So by nature, chemistry enables us to make things that are useful for society. We translate molecules into ideas and products that could be useful for people. I'm Norman Wagner. I'm a professor at the University of Delaware in the Chemical and Biomolecular Engineering Department, and our company's called STF Technologies. I'm very proud of the team that we've assembled. It's a very interdisciplinary group. A number of years ago, we were working on these shear thickening fluids. Shear thickening fluids are very unique materials because they're field responsive fluids. The harder you push, the more it pushes back. That kind of response, which is not the normal response, can be harnessed in a creative way. We're trying to really provide protection where it doesn't exist. They might benefit first responders, police, military. One of our products that we're working on right now is with NASA to protect astronauts. And you'll see Rich and Eric and Maria and others trying to formulate special chemical formulations that'll withstand the rigors of space, especially when we start talking about living and working on Mars. Some of the early work we did in ballistics and puncture resistance for body armor translates over to things like puncture-resistant medical gloves for use by surgeons.
I have an ice pick here. If you stab the conventional Kevlar, you can see you very easily go through. I use the shear thickening fluid treated Kevlar. You can't get through.
Our partnership with the Army Research Lab is really essential to enable us to translate and take our ideas out of the laboratory and bring them into the real world practice.
We had this idea that if we could get the response of a shear thickening fluid, but in something that's more like a strap that is speed dependent in its response, you could potentially make some sort of supporting wearable devices that could prevent concussions and head injury. Working with chemists is great and it's really important. You really need a chemist in there to do the details of how do I get this material to be compatible with that material. From there, once you have a technology that's new and different, it can do something that no other material can do, then just applications will come to you, things you can't anticipate.
And when you talk about prosthetic devices, the ability to provide people with a more realistic, lifelike prosthetic device is really critical to balance out the gait.
To be able to use the fluid to dampen the forces to a limb would be pretty remarkable.
You try to match the range of motion and the kinds of forces that the patient would feel.
Basically, we're trying to use these shear thickening fluid tethers to customize it to each specific patient, each specific person. So that way they don't have to switch out, oh, I'm going to go running today, I need to use a different prosthetics. It's definitely a team collaboration, and I'm happy to have a team.
Our business is inherently interdisciplinary. We need talents and skills that go beyond any one particular discipline. Chemistry is at the heart of it, but there's so many other science and other soft skills that have to come together to be successful. And that playground is vast, and the opportunities are enormous to be able to do this.